This will cover the mechanistic philosophy, or the philosophy presupposed by science, from an Aristotelian perspective. Now, what the world looks like through the eyes of science, or through the eyes of mechanistic physics, seems insane. I think even to the commonsensical view, and especially from an Aristotelian perspective. Where we find that the mechanistic philosophy claims that even qualities are subjective. We find the mechanistic philosophy to be surprisingly subjectivist about everything else besides the measurable aspects of physical bodies. That qualities are merely subjective phenomena and not properties inherent in physical things. Thus, there is something else going on besides a materialist philosophy. The mechanistic philosophy is even more repulsive, and strikingly so. For they not only say that the only things that exist are physical things, or that nothing exists that is separable from physical things, like a sort of standard materialist position would hold. That colors are really properties of bodies, that qualities are objective properties inherent in physical bodies, but that that they're not separable and don't exist separately from physical bodies. But the mechanistic philosophy claims that everything that is not measurable is subjective phenomena. And that is because the science of mechanics simply doesn't take into consideration qualitative change. The science of mechanics, of Archimedean mechanics, the mechanics of Archimedes, considers only weights, sizes, speeds, position, in the sense of leverage. And so when physics is restricted to a mechanics, when a mathematical physics is restricts the domain of physics to mechanics, the only relevant aspects of the physical world will be the relevant aspects of mechanics. And that's quite what happened. And the philosophy presupposed by that, the epistemology, that only the mechanistic aspects of things can be known. Only the mathematical aspects of things can be known. And here they're not talking about arithmetic and geometry. They're not talking about the world of forms. They're talking about what can be measured. When only the mechanistic aspects of things, the concepts relevant to, and the variables of the old mixed mathematical science of mechanics, which already provided a mathematization of physics in that sliver of a domain. That physics is restricted to the mechanistic attributes of things, since there can be no mathematical formulation of qualitative change or of growth and decay or of generation and corruption. These things are just written off because they don't factor into the science of mechanics. So their maneuver is to make anything that is not a measurable aspect of physical bodies subjective. That qualities are mere subjective phenomena. Because they restrict physics to mechanics and the epistemology or even the procedures of mechanics are obviously such as to exclude other domains outside of physics. And this was most evident in Descartes' thought experiment of wax, his thought experiment about the nature of wax, wherein the qualities such as hardness and softness, since wax might at one time be hard and at one time soft, or at one time brittle, and at another time malleable, and at one time warm and at another time cold. Those qualities, he argues, are not objectively in the wax, but all that is there is extension and movability. So that there's not even a substance, like a kind of thing, which is wax. Even substances and accidents, or substances and their properties, essential properties, are out the window. The only differences in things are said to be their measurable aspects of the same matter. Their extension, weight, speed, position, things which factor into the science of mechanics. But beyond that, for the mechanistic philosophy, nature is inert. Nature is inert and inactive. That physical things have no active capacities, they have not capacities to act on others in the broader sense of the word, to act or active. As fire has the capacity to heat other bodies and ice has the capacity to cool. Now, what is cooled by ice is passively cooled, while ice is an active force and has a capacity active. As well as of animated things, of living things. They are, through the eyes of the mechanistic philosophy, inanimate weights, because in the science of mechanics, the mechanics of Archimedes, there is no consideration or relevance of activity, of an active cause of anything. But one weight acts, quote unquote, on another weight in a way that leaves no room for animation. The science of mechanics does not consider anything as moving itself or as having a capacity to affect anything, qualitative or directionally movement. And so what the world looks like through the mechanistic philosophy is inert and lifeless. Physical things are mere inanimate weights, since the science of mechanics only considers things insofar as they are measurable or have a certain position, and only consider their movements insofar as they are pushed from without. The only sort of causality in science, in the scientific worldview, in the mechanistic worldview, is things being pushed from without. There is no room for animation or activity because they play no role in the science of mechanics, which is what the new science restricted physics to. Because those things could form an exact mathematical science of physical things. And that distinction between primary and secondary qualities, between the measurable aspects of things and the qualitative aspects of things, whereby the measurable aspects are objective and the qualitative are subjective phenomena, but also substance and attributes, categorical distinctions, species, essences are deemed subjective, as even wax as a substance is mere extension, the same matter as any other substance. They thus write off the whole Aristotelian paradigm of substance and essential properties. And fire is for them not hot. Heat does not exist objectively in fire, nor does luminosity. Those, because they cannot be measured. They are subjective phenomena in a perceiving subject. What exists in fire is merely motion and the mechanistic aspects of things. They're corpuscles and textures. But even hardness and softness, brittleness and malleability, according, and warmth and coldness, according to Descartes, are subjective phenomena and don't exist objectively in the wax, nor is there a substance of wax. The only thing really out there of the body of wax is extension, the ability to be moved, not to move, not a capacity to affect any qualitative or any other kind of change. But nature is for them an aggregate of inanimate weights, of only measurable properties. But I would rather just begin because I have written this in a more thoughtful way. The primary problem with the mechanistic philosophy is this. Epistemologically, certain knowledge is limited to not even physical things, but to the mathematical, mechanical aspects of physical magnitudes, whilst everything else is excluded from scientific knowledge, or what is the same from certainty. But that is a most peculiar and unusual phenomena, of which an account ought to be provided for. The congruent problem concerns the metaphysical suppositions of the mechanistic physics, of a mechanistic physics. A distinction is drawn between things that are objective and things that are subjective, whereby the mathematical and mechanistic aspects of physical magnitudes are said to be objective, whereas everything else, including qualities especially, but also species and genera, and even words and ideals, are written off as subjective phenomena, not really inherent in bodies outside of a perceiving subject. Of course, then the ideals and values of ethics and metaphysics and things like that, and the like sorts of things which were previously mentioned, also fall victim to that distinction and are classed as subjective phenomena in a perceiving subject rather than objectively out there in the world. Oddly enough, the philosophers of the 17th century, who we would not usually class as scientists or natural philosophers, such as Locke, Descartes, Hobbes, among others, were the ones who explicitly stated the mechanistic philosophy and who formulated the epistemological and metaphysical framework for the new science, which is blindly or instinctively presupposed by those within the confines of the scientific outlook. But since trained physicists and chemists never study early modern philosophers and think them to be disposable literary figures, they fail even to appreciate the scientific outlook and to confine themselves to narrow and tedious activity. I would emphasize that the works of Huygens, Mersenne, Wallace, and other 17th century natural philosophers who really were aware of the project and direction of the new science, that they have not even been translated into English. That contemporary scientists think they are just as well off in terms of their education and training, collecting a disarray of cataloged facts through textbooks and reading scientific journals in the most current theories, as they would be by studying the writings of Descartes, Mersenne, Huygens, and the like, shows a sort of disrespect for their own movement or tradition that is painful even to the onlooker who would contend with them about heliocentrism. If they had, they might not continue to quibble over particles and waves of light and realize that both theories meant that light is a subjective phenomena, stimulated only in a perceiver by the motion of the same corpuscular particles, the same particles of which they say compose solid bodies, of which the solidity, again, is merely a subjective phenomena of, quote, mostly empty space and some corpuscles. I mean that we don't realize the extent to which they deem qualities in the broadest sense as subjective, as even light is merely a subjective phenomena. But what are really out there, the particles of light, are the same atoms. And this is clear in the writings of Descartes and Hobbes and Newton. Just as solidity is also not objectively in the earthen body, but is a subjective phenomena in a perceiver of that body. Thus, subjective qualities which are subjective phenomena include light, as well as color and all else, as well as solidity and heat and hardness and softness. Hardly anything is accounted as the measurable aspects, the mechanistic aspects of things. They would find that Descartes' meditations, his doubt whether he is dreaming, refers to the scientific outlook, whereby the only objective things which really inhere in bodies are the mathematical and mechanistic aspects of things. That is what can be measured. And that all qualities are subjective phenomena. That even the wax from his thought experiment, aside from its extension and movability, is subjective phenomena. That even what we call wax is not a kind of substance at all. They would see that Descartes' meditations and his doubt whether or not he is dreaming are meant to orientate readers with the scientific outlook, to situate them within the mechanistic worldview, within which nothing is objective except the mechanistic aspects of bodies that can be measured and described mathematically, to show them what the world looks like through the eyes of the mechanistic philosophy. When, quote, by convention there are sweet and bitter. By convention there are hot and cold. By convention there is color. But in truth, there are only atoms and the void. That quote is from Democritus, but quite accurately shows that Descartes' meditations and his doubt whether or not he is dreaming are a response to the mechanistic physics, which denies the objectivity of qualities. That is what he is getting at. And that's what spurs his meditations about whether or not he is dreaming. That everything that is not mechanistic is subjective phenomena, the matter of the imagination. However, the scientific outlook has become such that the epistemological and metaphysical premises of mathematical physics are unawares presupposed, or rather, not even fathomed in full. But through custom and habit, mechanistic physics functions like a directionless and aimless procedure. But those epistemological and metaphysical premises shall be what precisely we have qualms with, that everything besides the mathematical aspects of physical magnitudes is subjective, even everything within the human domain, but that only the mechanistic aspects of physical magnitudes are objectively really out there in the world, and that congruently, scientific knowledge and certainty are restricted to the mathematical aspects of physical magnitudes, whilst everything else is dismissed as a matter of opinion and custom. In the mechanization of the world picture, E.J. Dijksterhuis, written around 1950, accurately attributes the emergence of the scientific outlook and the mechanistic philosophy to the primary-secondary quality distinction. That distinction is crucial. And that is a metaphysical distinction. I should say that metaphysics is not just what exists. Metaphysics is concerned with the distinctions between subjects and attributes, between essential properties and accidental properties, between properties with which a substance remains that kind of substance, and between properties without which the substance would not remain that kind of substance, such as a triangle having three sides or having angles equal to two right angles versus having a particular angle or a particular magnitude. The distinction between essential properties and accidental properties is the kind of metaphysics that is crucial and is not fantastical or make-believe and is not as naive to just from the start, just as what exists, that how metaphysics is taught, where we're distinguishing between substance and attributes, essential attributes and accidental properties. Like this distinction between primary and secondary qualities, where the primary are objective and the secondary are subjective, where the primary are the measurable aspects and the secondary are the not measurable qualitative aspects. Those distinctions are the maneuvers of metaphysics, which cannot be avoided. You cannot avoid metaphysics. Everything underneath science is metaphysics. Everything beneath anything is metaphysics. The question that we have arrived at of whether metaphysics is even possible results from an inadequate understanding of even what that is. We're not asking just from the start, what exists? There are all these unavoidable maneuvers, such as difference between essence, the essence of something, and the how much or the qualities of something. An essential kind and the properties like magnitude, quality, the where and when, categorical distinctions, none of that is avoidable. This primary, secondary quality distinction is a metaphysical distinction, and those kinds of things are the perfect example of what sorts of metaphysical maneuvers cannot be avoided and does not seem like something out there in a difficult realm. So to continue, we find that metaphysical distinction which underlies the new science unanimously accepted by Galileo, Descartes, Locke, Hobbes, and generally speaking, all the moderns. And that is no unpermitted generalization. For Leibniz in 1671 said that, quote, all modern philosophers desire to explain natural phenomena mechanistically. That distinction I refer to between primary and secondary qualities underlies as a presupposition the mechanical explanation of phenomena, as even the term phenomena carries with it a presupposed sense of subjectivity, that phenomena are not real characteristics of and belonging to physical bodies and are not really out there in the world. Thus, figures like Hobbes, Descartes, and Locke, as well as Boyle and Galileo, all adhered to the mechanistic worldview, which is presupposed by an exclusively mathematical physics styled after rational mechanics. From this perspective, the distinction between rationalists and empiricists seems like something trivial. For we find also that both camps affirmed the law of inertia, the Copernican cosmology, and the scientific program as a whole, as well as a simplistic disdain for scholastic disputations and dialectic, and a metaphysics. The rationalists who dominated the 17th century indeed advocated more fervently for an exclusively mathematical physics. Those are the rationalists like Descartes and Leibniz, who invented an algebra which did not calculate numbers or anything counted, but anything measurable, and distances and geometrical, and algebra for geometry and physics. And Leibniz, the other rationalist, who developed calculus for instantaneous velocity. These were discoveries aimed at the new science, at founding the new science, or providing the new science with the proper tools. But the empiricists, following Boyle and Locke, equally affirmed the subjective-objective distinction between mechanistic attributes on the one hand and qualities on the other, that presupposes or is presupposed by a mathematical physics, even if experimentation is to have a role therein. But I should say that the scientific method as presented today of basically experimenting and checking if something is a fact, making a hypothesis and experiment, does not specify as to a mathematical physics, nor to the avoidance of qualities. Merely making a hypothesis about anything is insufficient to account for what is going on in mathematical physics when they are working with algebraic equations. When mathematical physics is presented as algebraic equations, to merely make a hypothesis just about anything, and to make an experiment about anything would not amount to what is going on in mathematical physics, or whatever has. Nonetheless, the rationalists and the empiricists both equally affirm the subjective-objective distinction across the board. Dijksterhuis, in The Mechanization of the World Picture, tracing that metaphysical distinction through from Galileo to both Descartes and Locke, states that Galileo was one of the first scholars to proclaim an idea which, as an essential consequence of a conception of nature in which only properties which could be determined geometrically and mechanistically were considered as real, gained many adherents in the course of the 17th century. This was the notion already found in Democritus, that sensual qualities such as color, taste, and odor are not to be regarded as intrinsic properties of the bodies outside ourselves, but that the perceptions which had formerly been attributed to the presence of those qualities are merely the result of the way our senses are affected by that which alone really exists, the atoms and their motions. This was the beginning of a development which in Locke was to lead to the definitive discrimination between the geometrico-mechanical qualities, referred to as primary, and all others, which are called secondary. although they were in some sense drawing from Democritus's claim that qualities are subjective phenomena. Whereas Democritus had only allowed atoms in the void's objectivity, the scientific outlook was designed to delineate mathematical aspects as objectively in physical bodies, whilst retaining the Democritean exclusion of qualities and categorical distinctions. The fact that Galileo, Descartes, Boyle, Locke, Newton, and Hobbes were all qualified atomists and in practice explained qualitative phenomena in terms of the motions of corpuscles or particles, which played precisely the same role as atoms did for Democritus, but allowed them to avoid the logical inconsistencies of indivisible particles. That is less significant than their purpose for ruling out qualities. That is a mathematical physics. We have to first discern that. I mean that their aim was to exclude from physics anything that couldn't be explained in the manner of rational mechanics, the mechanics of Archimedes, which had provided the template for mathematization and the standard for an exact science about physical things and their processes. The fact that they periodically flounder into atomism is less significant of their project, which is more so distinguishable as an attempt to attain the kind of mathematical certainty, as well, importantly, a mathematical precision in physics, which was previously exemplified by rational mechanics. Their simultaneous corpuscularian leanings, verging on atomism, although problematic and indicative of their influences, should have to be considered separately. An inquiry into why Newtonian mechanics would speculate only about the motions of particles, and why both Newtonian and Galilean mechanics would speculate about motion in a void and not through air or any other medium, would detract from the significance that they, whilst concerning themselves with the foundations and principles of physics as a whole, were working within the subject previously denominated as mathematical mechanics, not physics. The most explicit description of the boundaries, aim, and foundations of the new science was provided by Descartes, in whom we find physics not only inseparable from the procedures of mathematics, but as identified with mathematics or a part thereof. Descartes simply identified physics as a part of mathematics. The following passage is again from the Mechanization of the World picture. Cartesian physics is studied by means of des raisons de mécanique. It is mechanistic in character. This implies that it uses no explanatory principles other than the concepts employed in mechanics. Geometric concepts such as shape, size, quantity, which are used by mechanics as a department of mathematics. And the concept of motion, which forms its specific subject. It recognizes as actually existing in nature only those things which can be described and explained by means of these concepts. It not only excludes all notions of animation, internal spontaneity, and purpose, but also denies all internal change in the particles of matter, which it looks upon as the ultimate building blocks of perceptible bodies. It also banishes from physics all secondary qualities, which it regards as states of consciousness. The gulf between this wish and the application of metaphysical principles such as potency and act is indeed enormous. Cartesian physics, along with also the regrettably overlooked physics of Thomas Hobbes, provides the complete project for which the appalling distinction between primary and secondary qualities was aimed. That is to say, the distinction between the qualities of physical bodies as subjective phenomena and the mechanistic or geometrical attributes as objectively in physical bodies is only serviceable for a mathematical physics. Yet we should also have to know why mechanics, as well as the other exact semi-mathematical sciences, such as optics and astronomy, which indeed existed before the new science and were their template, would ever have the pretensions, or would ever have had the pretensions of casting aside all other subjects of knowledge and formulating a metaphysical and epistemological scheme in their place. Nonetheless, we are brought to another unsettling metaphysical presupposition of the new science, that the motions of things are only considered insofar as they are moved from without, or in other words, things have no internal principle of motion, neither of movement in place, nor of qualitative change, nor of growth. But in accordance with rational mechanics, bodies are only considered insofar as they are inanimate and pushed or pulled from without. Nature is thus lifeless, inert, and dead. Or that is at least how nature looks through the eyes of rational mechanics, which is meant to speculate only about the passive motions of inanimate bodies moved from without. Physical bodies such as fire, liquids, and solid earthen bodies, as well as plants, animals, and men, are seen only as inanimate weights, as qualityless geometric magnitudes, inactive and inert. They are, besides not having internal principles of movement and activity, stripped of their capacities to effect qualitative change in others, such as that of fire to heat and illuminate, as well as of their capacities to be qualitatively changed. By now, it should be clear that the difference between Aristotelian physics and the new science of the moderns does not come down to whether or not something or other is a fact. We shall, however, have to further consider the relevance of the view that nature is inactive and inert, that physical bodies and different substances are without dispositional capacities to effect qualitative alteration in others, as well as without capacities and predispositions to be qualitatively changed passively. Yet, although qualitative change and the processes of growth are quite nearly written off as subjective phenomena, without existence outside of a perceiving subject, the denial that bodies have principles of movement or internal impulses for directional motion make for a more direct explication of the departure of a mechanistic physics from the view that nature is inactive, the departure of a mechanistic physics from the view that nature is an active force in things to the view that natural bodies are inanimate, inactive, and incapable of initiating movement or change. The relevant concepts of the science of mechanics, or the variables relevant to that science, are essentially geometrical, or were, when they picked up the science of mechanics from the works of Archimedes. Qualitative change plays no role therein. And so a mechanistic physics can only analyze qualitative change in the processes of growth into mathematical concepts such as sizes, weights, speeds, and distances, and then prove conclusions about qualitative change by synthesizing assertions from those basic mathematical concepts and propositions. From the dawn of rational mechanics, the quality of weight was the first to be mathematicized. Now, geometric shapes have no weight, only physical bodies do, nor are numerical values inherent in weights. Thus, weight is not quantitative itself, but is a physical quality whose difference of more and less can only immediately be measured when different weights are compared in ratios to which proportional ratios are drawn between arithmetical numbers. The science of mechanics always had represented weights as rectilinear areas in order to mathematically prove things like how a lesser weight can move a greater weight, that is, by the aid of a lever. Obviously, that sort of mathematization of qualities can only go so far without becoming totally reductive, and was bound to ultimately exclude from objectivity qualities which cannot easily be represented as proportional areas or numbers. That process is responsible for the theory that colors, for example, are subjective phenomena, the only corresponding objectivity of which are mathematical wavelengths of the motions of particles, which are not only dissimilar, but categorically different from the qualitative phenomena we associate with different colors. According to the author of The Elements of Early Modern Physics, this mechanistic philosophy thus recognized very few real qualities and in its purest form, but one means of action, namely pushing. That one means of action and causation, pushing from without, cannot, however, be thought of as an active force, initially in and set forth from any physical body. That is, what moves something which is passively moved, what moves something which is passively moved is itself not active, but is inert, and must have been indifferently pushed by something else previously. Natural bodies and everything in nature are but dead weights, impotent and inactive, without capacities to affect or be affected by qualitative change, and without principles of movement, by which certain substances are disposed to move in certain directions, such as air outward and fire upwards and solids downwards. Instead, there is not anything in nature which acts upon anything else, nor which is disposed with a capacity to affect anything qualitatively or directionally. As nature and everything in nature are inactive and inert mathematical magnitudes, sterile and without quality and internal principles of motion. Although the mechanistic worldview is most easily designated as inanimate, since living creatures are to them inanimate magnitudes or mechanisms. That is only a secondary and more specified application of their general and more accurate characterization. That natural things are not only inanimate, but inactive, inert, and without capacities or powers of initial movement directionally and of capacities to affect qualitative change. The view that natural things have no capacities to initiate qualitative change. The view that natural things have no capacities to initiate qualitative change and movement is only afterwards applied to living creatures, which are then deemed inactive and thus inanimate. The wider claim that nature is inert and without active capacities is more primarily concerned with not living creatures, but simply material substances such as solids, liquids, fire, and the various composite bodies. They are primarily concerned with claiming that fire is not disposed to move upwards from within, but is pushed from without. As earthen bodies, they claim, are not disposed to move downwards, but being without an internal principle of motion, are indifferently moved in any direction from without. And along with that, they are quick to refuse that fire has the capacity to heat actively and the capacity to illuminate proximate bodies, or that liquids have the capacity and power to moisten proximate bodies, and the sun to dry and likewise to heat. Those active powers or capacities to affect qualitative change are written off with the restriction of qualities from objectivity altogether. For warmth, they would say, is not a property objectively in the air or a property of air on a sunny day, nor are the properties hardness or sharpness in a bronze sword, but are only subjective phenomena to a perceiving subject. Again, when they speak of qualities as subjective phenomena, they are not just talking about colors, but even things like hardness, softness, sharpness, dullness. They are really including all those things, light, as well as lightness and heaviness, more than people think. But we should have to briefly digress to inquire why a mechanistic physics and a corresponding mechanistic worldview would be want to exclude from natural substances internal principles of movement, spontaneity, and capacities to affect qualitative change. Why they would be want to even do that. Recall that the mathematical physics of the 17th century allowed only the concepts used in the science of mechanics, and explicitly so, such as sizes, speeds, distances, and weights, as explanatory principles of physical processes. Descartes made that clear. Huygens, Malebranche, they all stated explicitly that the only explanatory principles are mechanistic explanations. The common problem in mechanics. This will be clear if we look at what mechanics was the science of. The common problem in mechanics is how, with leverage, a lesser weight can be used to move a greater weight. That is, by placing a lesser weight and a greater weight in a balance at distances inversely proportional to their weights, they will be in equilibrium. And when the lesser weight is placed at a distance that, in comparison with the distance of the greater weight, exceeds the difference between their weights, the lesser weight will move the greater weight upwards. Thus, if the difference between one weight and another weight, if they are unequal weights and they're placed on a balance, that can move up or down in either direction. And the lesser weight is placed at a distance which proportionally exceeds from the distance of the greater weight, the difference or the ratio between their weights. The lesser weight will push downwards, and that will transfer the weight. The lesser weight will, the motion of the lesser weight downwards will be transferred to the upward motion of the heavier weight by leverage, by placing the lesser weight at a greater distance. You can, in theory, move any weight. A weight that cannot be moved, you just use a lever, or this is clear in a balance, where the lesser weight just needs to be extended further. The arm of the lever of the lesser weight is extended further and the heavy weight is lifted by the lesser weight. That is all wonderful. But the science of mechanics considers not their motion according to nature, but is rather meant to affect motion contrary to nature, of earthen and liquid bodies upwards, for example. A particularly favorite problem of the early moderns was the motion of projectiles and the angle at which a projectile travels furthest. When the downwards natural motion of an inanimate body is combined with a horizontal or diagonal motion to produce a parabola of a parabolic trajectory. Such problems concern physical bodies only insofar as they are inanimate, and only considers their motions insofar as they are artificially produced or caused from without by not mechanisms in the sense of machines, but by positional leverage. The mechanical problems of Aristotle and Archimedes, for instance, are set towards effecting a motion which would not occur by nature, but which is affected artificially by simple devices such as balances, levers, and pulleys. The problem of lifting a body that could not otherwise be lifted with the aid of a pulley is reduced to a geometrical problem in the science of mechanics, whereby the only relevant variables are the angles of the chords of the pulley, the ratio between the heavier weight to be moved and the lighter counterweight, and their distances along the chords from the pulley. Those are the relevant variables. So you can see how things are reduced to those sorts of things in mechanics. And then when the physics is reduced to mechanics, the same sorts of variables are the only relevant aspects. The affected motion of a heavier body displaced upwards by the force transferred from the weight of a lighter body simply would not occur according to or by nature. Those are the sorts of tasks and mathematical problems upon which the paradigm of a mechanistic physics and the mechanistic worldview were founded. And the relevant and accepted variables consequentially exclude from physical bodies internal principles of motion and capacities to effect qualitative change. Aristotle distinguished motion according to nature, such as that of earthen bodies downwards and that of fire upwards, and violent motion contrary to nature, such as earthen bodies upwards and fire downwards. Mechanics is, for the most part, concerned with violent motion, or what is called violent motion, contrary to nature, motion contrary to the natural motion inherent in bodies, such as the motion of projectiles and of heavier bodies moved by lighter ones. The violent motion of bodies contrary to nature is always caused by a force external to them, whether that be the motion of another body or a weight. Yet all physical bodies, even those which are inanimate, such as fire as well as earthen, have a principle of motion with which they are moved from within, or with which they are directionally disposed to move, without being pushed by an external force, such as air outwards. We would not say that they move themselves, since they are not disposed to move in any other direction and cannot stop themselves, but that they move in that direction naturally, or are disposed such by nature, such as as a substance, they are disposed in that direction, as fire is disposed as a substance upwards. The science of mechanics, however, is only indirectly, if ever, concerned with the natural motion of each kind of body, and is only concerned with their motions insofar as they are transferred from the motions of bodies external to them, such as the displacement of a heavier body upwards by the transferred force of the weight of a lighter body downwards, when positioned with leverage in a balance or with a lever. Notably, the science of mechanics does not crudely consider the collision of bodies in terms of only their weights and speeds, which is often how physics is presented. I mean, as the common image of the collision of billiard balls. But the science of mechanics considers primarily the transfer of force and motion via leverage and positional weight. What should also be said is that just as external forces that displace heavy bodies are not conceived, what should also be said is that just as external forces that displace heavy bodies are not conceived as brute pushing, as the problem is how to move a weight with ease that could not otherwise be moved. And the answer is never with more force, unless that be obtained by positional leverage. So also, the force is not conceived as a crude engine, but as another weight positioned rightly. Thus, the lever isn't even pushed downwards. The lever isn't even pushed downwards with what we might call a force to lift the heavy body. But a lesser weight is placed at the longer end of the lever, so that the force required to lift a heavier body upwards, the force required for that is simply the weight of a lighter body positioned with leverage. Although the science of mechanics has not as much to do with what we think of as machines as has been supposed, and a great many machines probably are not even designed with statics, kinematics, and dynamics. There is a sort of analogy which has prevailed, which sees the world as a machine. Now, this is derived from the characterization of nature as a whole as inanimate and mechanistic, without active capacities and internal principles of motion. Descartes even, and a great many like him, thought quite plainly that animals are machines without internal principles of motion and without vitality, as things inanimate. In La Mettrie, one of the most outright materialists, the Frenchman, thought that man likewise is an inanimate machine that reacts deterministically to stimuli. And in other senses, Descartes is in agreement with him. For Descartes says that I should like you to consider that these functions, including passion, memory, and imagination, follow from the mere arrangement of a machine's organs every bit as naturally as the movements of a clock or other automaton follow from the arrangement of its counterweights and wheels. And in his discourse on method, he gives the impression that the human body, at least, is a mere mechanism. That the human body, at least, is a mere mechanism. That the heart and the circulation of blood function mechanically. Recall that rational mechanics theorizes about physical bodies only insofar as they are inanimate weights, and not insofar as they have directional principles of motion internal to them. Definitely not insofar as they have a principle of vitality and active motion. So when science turns to the study of human beings, They are similarly thought by scientists to be inanimate machines, which deterministically react to stimuli. And this is always what the scientific opinion of mankind has been, as indeed is also the current trend in neurology, behavioral sciences, and sociology. All of those consider people as inactive, not having a free will, and not as agents, as their behavior being predetermined by statistical variables, such as the economy. And neurology is the particularly dangerous and deceptive and most nuanced of them, except the rest are quite similar and have a sociological or societal impact that is regrettable. And there is great reason to be repulsed by the mechanistic philosophy's estimation of human behavior as deterministic and the processes of thought as determined mechanistic reactions to chemical stimuli. There's great reason to be repulsed by that. All those are also just presuppositions of a mechanistic physics for the reasons that mechanics, which is the template for the new science, sees not even qualities. So when they turn to the human domain and to society, they likewise only see what can be statistically input to sorts of equations. The passions also, such as love, hate, pride, shame, honor, and the like, the mechanists think to be merely chemical reactions with no objective substantive basis. The scientific perspective of humanity is thus bleak and repulsive. To call them atheists is to yield far too much ground. For from the mechanistic perspective, there is no soul, no animating principle of living creatures. Animals and people likewise aren't even alive and self-motive, according to the scientific outlook, but are mechanisms or machines with deterministic responses to external stimuli. And this all follows from their refusal to admit that fire as a substance has a principle of motion upwards, an internal principle of motion, and is not pushed or pulled by anything else in that direction. Or that other, indeed all other physical bodies have a principle of motion internal to them, by which they move according to nature. But as the science of mechanics concerns not the internal principles of motion of physical bodies, when science turns to the human domain, people likewise are inert, inanimate. When science turns to the human domain, people likewise are inert, inanimate weights without agency or active capacities. The concluding chapter of the mechanization of the world picture provides this analysis while considering the possible meanings of mechanistic. Instead of mechanistic meaning machine, we arrive at a different conception if we consider a negative characteristic, the inanimation proper to a machine, the disability to function without an agent, the necessity of being set and kept in motion from without. Conceived in this way, mechanistic is the antithesis of animistic, the essence of the replacement of Aristotelian by classical physics is then seen as the rejection of any internal principle of change and motion, which, if not actually interpreted as a symptom of life, is at least felt to be related to it, and in the attribution of all motions to external causes. Thus, instead of the oppositional positions of theism and atheism, which is the line along which most accusations and objections to the mechanistic philosophy are set, the primary opposition is rather between animate and inanimate, between living and lifeless inertia. For what is primary and foundational to the scientific outlook is the view that physical bodies don't have internal principles of motion. Neither earthen bodies downwards, fire upwards, the heavenly bodies circularly, nor animals and humans as self-moving. And that is to deny agency in the human domain. But perhaps even beyond the refusal that there is a free will in human volition, there is a further denial that people are alive and animated. The fact that to speak of the soul has become an obsolete and fantastical way of speaking only goes to show the effect of scientific thinking. For the soul means nothing more than living, such that what distinguishes animate from inanimate bodies is that the prior are living and so ensouled, as well as also self-moving. But that is far outside the boundaries of scientific discourse, because even internal principles of motion, such as the impulse of the substance of fire upwards, is marked off as non-mechanical and declaimed as, quote, occult. Yet living things which move themselves in more than one direction and which can stop themselves are even more difficult to conceive of mechanistically than substances which always tend in a certain direction. Thus, refusing that humans have self-agency is a consequence of the refusal that natural things have internal capacities to act in the broader sense, such as that of fire to heat and illuminate. Once animals are considered as machines, as Descartes thought, the seasons of the year, cycles of the moon, the evaporation of air. Once animals are considered as machines, as Descartes thought, and seasons of the year, cycles of the moon, the evaporation of water into air, and the formation of clouds and rain are thought to be mechanisms. Once those are all thought to be mechanisms, and the growth of plants to be lifeless chemical processes, the question of a creator God is besides point. For then nature is inert and lifeless. But the law of inertia meant precisely that. The law of inertia meant precisely that there is no principle of motion internal to any substance, neither earth downwards, nor fire upwards, nor the heavenly bodies circularly. And I can't help but notice how singularly they wished to show the planetary spheres and the fixed stars to not be composed of an ethereal substance with an eternal circular motion. Just as the substance of fire moves upwards, as if on its own without being pushed by anything external, so also the moon and sun and planets and fixed stars were thought to have a natural impulse circularly, as fire does upwards, not as if pushed along from without. But there is underlying the new science and things like the law of inertia, a certain principle of inertia, which disallows internal principles of motion in a broader sense than that of directional movement in place. Not only were earthen bodies thought prior to the scientific revolution to have an internal principle of motion downwards, as fire does upwards, but fire was thought to have the capacity to heat, an active capacity, the capacity to affect heat in others, as ice was thought to have the active capacity to cool. Those were sorts of capacities or powers in them to affect qualitative change in others. We might consider those capacities as principles of motion alongside their principles of directional movement, as internal principles of motion. Likewise, living things, both vegetative and animate, were thought to have an internal principle of change called growth, as well as animals and men an internal principle of self-motion. Just as, however, the law of inertia means that the bodies of fire have not a principle of movement internal to them, by which they are disposed as if from impulse to move upwards, just as the law of inertia meant that, and those of earth without a principle of motion downwards, but are only moved passively from without. And likewise, all bodies and all kinds of substances are viewed as inanimate and, generally speaking, inactive and impotent. So also there underlies mechanistic physics a sort of principle of inertia, by which fire has not the capacity to heat, nor ice to cool. For nature is, when considered mechanistically, through and through inert. That is, nature is inactive, as none of the natural bodies have capacities to act, in the sense that we think fire has the capacity to heat, and ice to cool, and liquid to moisten. That is the broader sort of thinking that went with the law of inertia, that again, at once characterizes nature as inert and inactive, shorn of any internal principles of motion and of change, whilst refusing that any substance has a capacity to affect qualitative change in other bodies. And this takes us back again to the primary secondary quality distinction. For the qualities hot and cold are but subjective phenomena, according to the mechanistic philosophy, not objective properties of fire and ice respectively, but are generated in a perceiver by the arrangement of particles. So a substance will not have capacities to affect qualitative change in other bodies. Fire is not hot, according to them. It doesn't have that property objectively, but is composed of rapidly moving particles which affect the subjective sensation of warmth in a perceiver, whilst the slowly moving particles of ice give rise to the subjective perception of coldness. Nor would they say that fire is luminous, meaning that the quality of light does not exist in fire as an objective property of that kind of substance, nor does any other quality. The only properties objectively in fire, they would say, are particles and their sizes and motions, as well as the size and motion of the aggregate mass. Nor are the particles of fire luminous and hot, or in any way similar to the qualities we commonly think of as being properties of fire. People underestimate Democritus's theory of the abolition of qualities, and likewise Descartes and Newton's corpuscular theories of light, which are in principle the same. The particles of light are not luminous, The particles of light are not luminous, but are the same solid particles which compose earthen bodies. Only the swiftness of their motion accounts for the luminous effect we perceive. But the luminosity only occurs in an observer and is not in any way an objective property of what we call a luminous body. There simply is no light out there in the world, neither for Democritus, nor for Descartes, nor for Newton. As colors are not objective properties of bodies, but are subjective phenomena. The perception of the motions of particles moving with trajectories of certain wavelengths. That is, as colors are not objective properties of bodies, they are subjective phenomena. The perception of the motions of particles moving with trajectories of certain wavelengths. Neither are the particles of fire luminous, nor hot, nor are the particles of whose wavelengths we perceive as colorful themselves colorful. But all particles are the same solid and qualityless points. Thus, fire, for example, is deprived of the capacity or power to heat and to illuminate, is deprived of that capacity or active power to affect heat in something else or to affect illumination of something. And that as a result of the distinction between mechanistic attributes as objective and qualitative attributes as subjective phenomena. And that distinction, again, was essential to a mathematical physics, a physics which restricted anything that was not mathematical, which restricted anything that could not be measured, anything that was not part of the concepts or relevant variables of the science of mechanics. Which again, mechanics was already a mathematical physics of sorts. Optics was already a mathematical physics. Astronomy was a mathematical physics that consider physical things not insofar as they are physical, nor insofar as they have properties as physical bodies or the composition or their composition or anything, but only insofar, optics only considers light insofar as rays of light are lines and reflect at angles. Optics considers light only insofar as rays of light are lines and reflect at angles in order to geometrically prove things in optics. Likewise, mechanics only considers physical things insofar as they have certain mathematical aspects, disregarding the rest of them. And that is natural for those sciences. As every science, each science only considers the aspects of things relevant to their science. As harmonics considers sounds only insofar as they have only insofar as their pitch has a ratio to another pitch. While grammar considers sounds only insofar as they are letters, but not insofar as they have a high or low pitch. Yet both of them consider sounds. Grammar does not concern whether a high and low pitch, and music does not concern whether or not they are words or phrases or what is, or even what instrument they are. only insofar as their pitches are ratios. So also mechanics considers the mathematical aspects of things. Physical things only insofar as they can be measured. But that becomes a reduction when physics is restricted to a mechanistic explanations. And when that becomes a philosophy, then we have a philosophy of engineers, of what the world looks like through an engineer blind to anything else. The idea that nature is inert and inactive is the direct contradictory of Aristotle's definition of natural things. His definition of natural things as having internal principles of motion and the capacity of affecting qualitative change and internal principle of growth, whereby nature is accordingly the power of change in natural things, inherent and internal. And that, along with internal principles of movement, is what distinguishes natural from artificial things. In Aristotelian physics, nature is the welling source of change and movement in physical things. Whereas in mechanistic physics, natural bodies are inert and without capacities to move and to affect and suffer qualitative change. That sort of principle of inertia renders nature lifeless, quite literally, which is, to our surprise, made explicit by them when they say that the processes of nature are mechanical, and that even animals are simply inactive machines responding deterministically to external stimuli. The second book of Aristotle's physics makes clear that he thinks nature to be a sort of power of change in physical bodies, and an active power as well as passive. Both the capacity to affect qualitative change and to move directionally, as well as of living things to grow and animals and men to move themselves. This is a reading of a portion of the beginning of his second book, where he defines what natural things are, what makes something a natural thing. Of things that exist, some exist by nature, some from other causes. By nature, the animals and their parts exist, and the plants and the simple bodies, such as earth, fire, air, and water. For we say that these and the like exist by nature. All the things mentioned present a feature in which they differ from things which are not constituted by nature. Each of them has within itself a principle of motion and of stationariness in respect of place, or of growth and increase, or by way of alteration. They have a principle of motion in those senses, and that's what distinguishes them from non-natural things. On the other hand, a bed and a coat and anything else of that sort, qua receiving those designations, i.e., insofar as they are products of art, have no innate impulse to change, but insofar as they happen to be composed of stone or of earth or of a mixture of the two, they do have an impulse to change. And just to that extent, which seems to indicate that nature is a source or cause of being moved and of being at rest in that to which it primarily belongs, in virtue of itself and not in virtue of a concomitant attribute. Nature then is what has been stated. Things have a nature which have a principle of this kind. Each of them is a substance, for it is a subject, and nature always implies a subject in which it inheres. The term according to nature is applied to all those things and also to the attributes which belong to them in virtue of what they are. For instance, the property of fire to be carried upwards, which is not a nature nor has a nature, but is by nature or according to nature. For those things are natural, which by a continuous movement originating from an internal principle arrive at some completion. The same completion is not reached from every principle, nor any chance completion, but is always a tendency in each is towards the same end, if there is no impediment. Just as when distinctions are made which exclude value judgments from meaningful statements, in which truth and falsity are said not even to appertain to value judgments, and when rhetoric or the art of persuading conviction is deemed something insignificant and cast off with the rest of the liberal arts. What we might call technological experts, unskilled in rhetorical persuasion and disbelieving of grand ideals and values, resort to social engineering to control the populace. Just as that is the case, so also when the science of mechanics banishes qualities and categorical distinctions from physics and lays the philosophical foundations for a mechanistic physics, we are left with a philosophy displaying the worldview of an engineer, or reducing everything to the sorts of variables which an engineer would find relevant to his practice, whereby everything besides mechanistic aspects such as weights, distances, sizes, and speeds are termed subjective phenomena, such that qualities are not objective properties of things. Again, to repeat from the mechanization of the world picture, Cartesian physics not only excludes all notions of animation, internal spontaneity, and purpose, but also denies all internal change in the particles of matter, which it looks upon as the ultimate building blocks of perceptible bodies. It also banishes from physics all qualities, which it regards as states of consciousness. Again, the mechanistic philosophy is defined by an epistemology which excludes from legitimate knowledge all subjects and topics which cannot be explained mechanistically, and concordantly is defined by a metaphysics which renders as subjective phenomena all qualities, as well as all categorical distinctions and attributes which are not mechanistic or mathematical. And in doing so, by applying the science of mechanics, which recognizes natural bodies only as inanimate weights, by applying that to all other disciplines, consequently describes nature as inert, lifeless, and without the active capacities of motion and change. Clearly, then, the problem of science does not come down to whether or not something or other is a fact, but the mechanistic philosophy as a whole, or we might say the scientific outlook, which is presupposed by a mathematical physics, has been for some time a problem to be solved.